In this problem, we're going to take a set of data and we're going to do a bunch of different things with it. We're going to make a table and we're going to make a graph. We're going to talk about domain and range. And then we're also going to add something new, which is that we're going to talk about whether our relation is discrete or continuous. So let's go ahead and read our problem. It says, at an ice sculpting competition, each sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. The measurements were as follows. Team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Team 4, 5.1 feet. Team 5, 4.8 feet. Okay, so let's look at all the things we have to do. The first thing says, make a table of values showing the relation between the ice sculpting team and the height of their sculpture. All right, well, making a table's easy. Our table here is going to have the team number in one column and their height in feet in the second column. That's pretty easy because the teams are very helpfully numbered 1, 2, 3, 4, 5. Okay, so team 1 was 4 feet. Team 2 was 4.5 feet. Team 3 was 3.2 feet. Team 4 was 5.1 feet. And Team 5 was 4.8 feet. All right, we made a table of values. Check. Next, state the domain and range of the relation and determine whether it is a function. Well, the domain is the set of all values that are in the input or the independent variable, which is the team number. So the domain is 1, 2, 3, 4, 5. That's easy enough. And the range is the same thing, but for the y's. So 4, 4.5, 3.2, 5.1, and 4.8. And is that a function? Of course it is, because each element of the domain, 1, 2, 3, 4, 5, corresponds to a different element of the range, which makes a lot of sense when we think about it, because a team could not have a sculpture that was two different heights. You could not have a function, or you could not have a sculpture that was 3 feet tall and 4 feet tall. That doesn't even make sense. So it is a function because no team, pen back here, no team has a sculpture that is more than one height. I don't even know how that would be possible to have a sculpture that was more than one height. That doesn't make sense. There we go. Done. Next, we're going to write the data as a set of ordered pairs and graph it. Okay, well, a set of ordered pairs doesn't sound bad at all. We're just going to write these out as coordinates. So team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Oh, run out of space here. Team 4, 5.1 feet. And team 5, 4.8 feet. Great. And then for the graph, I think I'm just gonna do a real quick sketch here. I'm gonna use a ruler. Even whenever we're sketching, we still want to use a ruler. Let's go. Yeah, I need to go up to at least 6, I think, too, because the maximum height is 6. So let's make sure it's tall enough. Even when you're doing a sketch, even when you're not using an actual sheet of graph paper, we still want to use a ruler. We don't want to be sloppy. My x-axis, I really only need to go to 5 because there's only 5 teams. All right, so this is going to be teams on the x-axis and height in feet y-axis. I suppose I should say team number, not teams number. Team number. Okay, so then our first point is going to be 1, 4, 2, 3, 4. So that's going to be about right there. Team 2 is at 4.5. Team 3 is at 3.2. Team 4 is at 5.1. and team 5 is at 4.8. There we go. That's a pretty decent sketch right there. All right, wrote it as ordered pairs and graphed the data. And now we're going to state whether it's discrete or continuous. And this is something that you may not have heard before. The difference between discrete and continuous, this graph, first of all, is discrete. And the reason it's discrete is because the points are not connected. That's all discrete means. The points are not connected. And they're not connected because we have a team 1 and we have a team 2, but we do not have any teams in between those two. So if we were to connect these points right here, what we would be saying is that we have a team 1 and a team 2, and we also have all the teams in between. This would be saying we have a team 1.1, a team 1.2, a team 1.3. Do we have a team 1.2? No, of course not. That's ridiculous. But that's what it means when we connect the points. We're saying we have 1, 2, and all of the points in between. That's what continuous means. And that can be a little tricky because when we think continuous, a lot of times we think of the English word continuous, which means ongoing. It keeps going forever. That's not what continuous means in math. Continuous in math just means the points are connected. Here, the points are not connected because we cannot have a partial team, like a team with a partial number in between. So that's why this is considered discrete.